right, so we have one more question about probability, and then we're going to talk about a few more things. And we're going to finish up our probability stuff, which will allow you to completely finish that homework assignment on the next 2 pages, all the circled problems. In math class, there's 14 seniors and 8 juniors. Of the 5 seniors are male and 4 of the juniors are female. So let's talk about the seniors for a moment. It says right here, 5 of the seniors are male. I could write a tree diagram. I'm not going to bother. Now, if 5 are male, that leaves 9 to be female. I know. I don't like these questions anymore. Let's just classify as male and female for today. I'm sorry. All right, then 8 juniors. 4 of them are, what does it say, female? So that means 4 are also male. What's the probability that you choose a student at random and it's a senior or it's a male? So I forget if we already discussed this formula. Yes, we did. So if they are not mutually exclusive, what you do is you'd add the probability of both things and subtract any overlap. There's other ways to get this right, but using the formula, because I want you guys to be recognizing this formula as useful when you move on to probability and stats. How many seniors are there? 14 out of how many total students in this class? 22. So 14 out of 22 plus, how many total males are there? Like between both classes or sections? There are 9 males, I think. But didn't we count some people twice? Who did we count twice? The senior males, these 5 dudes. So common denominators already exist. That's why I didn't bother reducing. Let's see, 14 plus 9 is 23 minus 5 is 18 over 22. Am I doing my math right? And I would expect PreCalc to reduce that. Cool, 9 over 11. Now, the other way to get that question right was just to say, okay, well, I have 14 seniors, and then who else would you have to add to that group to be considered senior or male? These 4 male juniors. So that's another way to get the 18 out of 22, and for most of you, you're like, well, that was easy. I'm going to do that. Yes, you can do that when you have context. If you don't have context, you have to follow that formula. So junior or female, you can use the formula, or we could skip the formula since we do have context. There are, let's see, 8 juniors, and then you're going to add in these additional females from the non-junior group, this 9 senior females. So that's 17 over 22, which does not reduce. And then the probability of you being a junior or a senior in this class. That's all of them, so that's 100%. So write it as 1. You can say 100% if you'd like. Okay. Talk about some risky operations. So fun. The surgery has a 25% failure rate. Rough go. Now, if the surgery works, you still have a 17% chance of infection. But, even worse, watch this. The surgery cannot work, can fail, and then you'll still get an infection 3% of the time. Oh man, that's terrible. What are the chances of a successful and infection-free surgery? So we're going to have to do some multiplying together because these are not independent events. They're dependent from one another, but we have probabilities that kind of go along with if this happens, then this happens. So successful surgery would be now 25% failure rate. Find the complement to that. So it's going to succeed 75% of the time, so 0.75. Times, and then it says if you're successful, which we apparently are, you still have a 17% chance of infection, so find the complement to that. What's the chance of you being infection-free? 83%. So even though they're dependent events, because we have their probabilities, you get to multiply them together like this, and you get something. I don't have it written down, so I need your help. 0.6225? Okay. So roughly 62%. Good luck, patient. That's terrible. That's not good at all. All right, a clothing store. Oh, this is so me. All right, so if you just buy the pants without trying them on, you have a 30% chance of them being too tight and a 10% chance of them being too loose. That's not quite me, but that's fine. I don't try on clothes. You know how many clothes I have in my closet that literally have the tags on, and I will never return them nor wear them? Such a waster. All right, what's the probability that you will purchase pants that actually fit? Well, they're either going to be too tight, too loose, or they're going to fit. So 100% minus 10% minus 30% gives you, that's right, kids, 60%. You have a 60% chance of having your pants fit. That seems like not true. All right, moving along. To meet standards, Harlem does research and discovers that 80% of students need help with math, 70% need help with English, and 55% of the students need help with both math and English. So find the probability that they need help with math or with English. This is a Venn diagram question at its essence, but we're going to use that OR formula. So math would be 0.7. Oh, no, it's not. It's 0.8. Sorry about that. And then English is 0.7. But we've double counted some kids, right? The kids who need help in math and English I've counted in both groups. So now we're going to subtract this 55%. Thank you. And that's going to give us our answer of 0.95 or 95%. Notice, guys, if you just add 0.8 plus 0.7, you get a number over 1. And that was one of the rules of probability. It has to be under 1. So you had a definite overlap there. Oh, I love these questions. These are the ones that you used to do in Algebra 2 all the time. So whenever you have what's called a contingency table, highlighters are really awesome for these. Now, unfortunately, on your SAT test, juniors, and PSAT for sophomores, you can't use a highlighter, so you just have to kind of deal with a pencil. But I still use highlighters to this day. So we're going to be asking you 3 different kinds of probability here. Just direct probability for a single event. We're going to ask you about conditional probability. And then we're going to ask you about combined probabilities, ands and ors. So be careful about the conjunctions and the wording and the notation that they use. So this first question says, what's the probability that you randomly choose somebody and they're an independent? So if it's not a conditional probability, that means your denominator is out of the total. So the total number in this chart is 140. How many of those 140 are independents? 17 of them. So if that reduces, I don't know, and I don't really care today. All right, production worker. It doesn't have a condition on it, so the denominator is also a 140. How many of our 140 are production workers? 92. Again, that reduces, but I don't really care. Independent or production worker. So the denominator is still going to be a 140. And this is how I like to do the question. I like to figure out the total, and then subtract off any overlap. So you don't have to do any highlighting, just kind of watch, because we're going to do some more highlighting in a second. But my independents are all these dudes, right, with a total of 17. And then my production workers are all these dudes with a total of 92. But do you see where they're overlapping? So you're going to be counting these 8 people twice when you add up these, when you use the totals. So what I do, I think this is the easiest way to do the question. I say a total of 92 production workers and 17 independents, but then I'm going to subtract the 8 independent production workers one time because I counted them twice. So what's 92 plus 17 minus 8 for my new numerator? Is it 101? So that is not the way that some teachers and some kids do that question. Some kids just go and they just add up the pieces of the chart that they need, and it is effective as long as you're careful. What I have found, especially at the Algebra 2 level, kids do not do that, right? So we just kind of stick with the add the total minus the overlap. It's a little more streamlined for kids, and it's less likely to have a mistake in it. Now here, this is where we most definitely need to do some highlighting, because this is the kind of question where you need to focus your attention on part of your data. This is a condition. So the probability of choosing an executive, given that you're looking only at Republicans. So this is the kind of question I see a lot on the SAT test. So you're only allowed to look at the Republican data right here. So your denominator is no longer the 140, it's only out of the total 55 Republicans. So out of these 55 Republicans, what's the probability that you were choosing an executive? Would be 34 out of the 55. And then similarly, with the independent given a production worker, that means you are only allowed to look at production workers, only that data. Get rid of that stuff, sorry. So my new denominator for this question, because I have a condition on it, what's your denominator for production workers? 92. And out of those 92 production workers, there's 8 independents. So yes, I do need to reduce these technically, but as some of us have seen on the SAT prep stuff, they often write probability as decimals, and if it is a fraction, usually it's a non-reducing fraction, they try to eliminate these extra things, especially if it's on a timed test, like the SAT test. You'll just crank it in your calculator if they want a decimal. Remember doing those in Algebra 2? I love those questions. Alright, counting techniques. We're going to make a tree. Remember that boy and girl problem? They had the tree diagram? This one's going to be a little less exciting. So we want to come up with all the possible outcomes for flipping a coin and then rolling a 6-sided number cube, okay? A 6-sided number cube. So flipping a coin, what are the 2 outcomes that are possible? Heads, tails. Now, after you flip the coin, you're going to roll the dice. Die. And you have how many outcomes every time you roll a die? And this one, it's 6. So you either are going to roll a... Should have wrote these smaller. Sneak one in here. A 1, a 2, a 3, a 4, a 5, or a 6. And then same thing down here. So trees are not really that exciting, except when you have something that's really hard for you to visualize. What's nice about a counting tree is when you get to the end of the branches, this is how many possible outcomes there are. So if you counted up all the little branches, you would see that there are 12 different outcomes. And if you follow the branches from beginning to end, that's the event itself. So like for instance, this one goes, land on heads, roll a 1. This one says, land on heads, roll a 6. So those are all the different outcomes. I think you guys are very familiar with how coins work, though, so we're going to skip investigating that. Let's take a look at this. Let's talk about counting techniques. This is the good stuff. So when I ask you about finding how many different outcomes are possible, the first thing I like to look for is what's called the multiplicative counting principle. What does your book call it? Well, we'll see. I call it counting principle. But in the class of 30 students, you have to choose a president, a vice president, and a secretary. And everyone can only hold one position. Now, some of you who have knowledge of this from Algebra 2 are going, wait a minute, isn't that a permutation? And the answer is yes and yes. This is not just counting principle, it's also known as a permutation. So counting principle is the easiest way for kids to think about these things, especially if you don't have a calculator, because none of you know how to find permutations by hand. So there's 3 decisions, 3 things that we have to think about: the president, the vice president, and the secretary. And when I go to choose this president, how many options do you have? You have 30 kids to choose from, right? So then you assign somebody to be president. So now for vice president, how many options do you have? 29. And then you only have 28 for secretary. And you're supposed to multiply your options together. And that tells you how many outcomes are possible. So some of you are going, wait, that's a permutation, Averzo. I agree with you. If you remember how to find this on your calculator, we're going to explore it in a minute. That is 30 permutations of 3 positions. And either way, you get the same answer. And what is that answer? 24,360? Cool. So a lot. Permutations get real big. All right, so let's revisit that 4 children's problem. Maybe I don't want to map out all the different birth orders that can happen with children. So they're going to have 4 children, right? And every time they have a child, they're going to classify them in the hospital as boy or girl. So there's 2 outcomes for the first kid, there's 2 outcomes for the second kid, there's 2 outcomes for the third kid, and 2 more outcomes. So how many total outcomes are there? That would be 16 different outcomes. So if we were finding probability, rather than me going through and writing out the sample space, because that would take forever, if I just needed to know like how many possible outcomes for my denominator, it's easy to do with a counting principle question. All right, now let's get into permutations and combinations. You use a permutation When order matters is usually the phrase that you hear from teachers. You're going to see words like arrange. Whoops, that's not how you spell it though. Arrange. Line up. Assign. Order. So anytime when you rearrange the order in which you select the items and it gives you a different outcome, that's a permutation. So for instance, when the president and vice president question came up, because we're assigning a role to each person, you know, Anna's president this time and Jenna's vice president, and I go, oh, never mind, Anna's vice president, Jenna's president, that gives you a different outcome, and therefore it's a permutation. A combination is where order does not matter. And you're going to see things like team, committee. I'm going to put the word choose. That's kind of misleading. The word choose shows up in both of them, but technically speaking, more often it shows up in a combination question. So if you're ever in a jam and you're like, I don't know, if it says the word choose, probably go with combination. Team, committee. If it says select a group, that's like a synonym for saying select a team. So sometimes kids get really literal with this and like, it did not say the word team. Well, if they're implying it's a team, it works the same way. So we have 32 people in our class. You're choosing 3 people for a team. How many possible ways can we do this? So is this a combination or permutation? It's clearly a combination. Now this, my friends, is how you do a combination by hand. Oh, fun. Who remembers what the exclamation point means? It is called a factorial. I thought you guys would be cutesy and tell me it meant n. That's what Algebra 2 always tells me. I was like, oh, no. But that's adorable. It's an excited n. It means factorial. It means you're going to take that digit and multiply it all the way down to the integer of 1. So when they're saying n items, we're going to choose r of them. So in this question, n is 32, and we're choosing 3 of them, so r is 3. So if you had to do this by hand, you would do 32 factorial over 3 factorial, and then 32 minus 3 factorial. Now that looks really awful. Like we wouldn't want to do that by hand, but if you did have to do that by hand, guys, it's really not that bad. Because 32 factorial is like 32, 31, 30, 29, blah, 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 3, 2, 1, right? I obviously took some artistic liberty there in the middle. 3 factorial is 3, 2, 1. And then 32 minus 3 is 29 factorial, right? So that's like 29, blah, 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 down to 2 times 1. Look what would happen. 3 2 1s would cancel. 29 and everything below it would cancel. So what do you have left? 32 times 31 times 30. Still not something I really would want to do in my head. But if push came to shove, could I do this in my head? Yes. Math team kids, you find that sometimes they make you do these without a calculator. Have you noticed? Maybe not on the geometry test, but when you guys get to Algebra 2 and PreCalc next year for a math team, they'll make you do some of these by hand, and you got to know to cancel them. The rest of us are going, that's great, Abruzzo. How do I do this on my calculator again? So we're going to go to the math menu. You're going to go over to the probability submenu. And then you have a choice of NPR or NCR, NCR being the combination one, so you would move down to number 3 or just select 3. And then you can type the N and R in, you can toggle between them. The first number that comes in front of the combination is the total number, and that was 32. And we were selecting 3. So apparently it's that. Nice, right? Much better to do it on the calculator than by hand, but you know, push came to shove. The SAT does not ask you about combinations and permutations, at least to my knowledge. I've never seen one. Watch this be the year. I never say never, because every time I say never, like the next year, they're like, hey, it showed up. I was like, dang. Oops. How many ways can 8 students be placed in a line? Now, is this a combination or a permutation? If I'm lining them up and arranging them, it's a permutation. So we're going to place all 8 of them in a line. So the easiest way for kids to do this usually is 8 permutations of 8. But guys, permutations are really the same thing as counting principle. So it means this. right? Because you'd just be 8, 7, 6, 5, 4, 3, 2, 1, which also would mean 8 factorial. So you have options, guys. You even have a factorial button in that cute little probability menu. Either way, you get a pretty big number. 40,320. I always thought this would be a fantastic punishment for, like, detention. Like, you 8 children. Find all 4,320 arrangements of yourselves. Go. Yeah, that probably wouldn't happen. All right, I want to choose a committee, keyword there, committee, of 4 boys and 4 girls from 20 boys and 15 girls. So it is a combination, but this is a series of combinations that we're going to multiply together. So you have a combination for the boys, and you're going to multiply it by a combination for the girls. So what do we have here? 20 boys, combinations selecting 4, times 15 girls, and we're selecting 4. And you can type that in one step on your calculator. You just got to make sure that you hop out of that subscript box before you hit the multiplication sign for your next combination. Or you can do them separately and obviously just multiply them together. You get a pretty significant number here, guys. 6, 6, 1, 3, 4, 2, 5, I believe. 6 million? Wow. All right. So combinations don't get as big as permutations, but obviously they can get pretty big. All right, and how many ways can I arrange? There's the keyword there, arrange. My videos and DVDs, because I'm old. On my shelf, if I have 5 videos and 7 DVDs, and all the videos are together and all the DVDs are together. So it's kind of like the boy and girl question where you're going to keep them separated, but you're still going to arrange them within their groups. So we're going to have to figure out a permutation, because it's ordering, of the videos, and we're going to multiply it by a permutation of the DVDs. So what are we doing here? I have 5 videos, so 5 permutations of 5 times 7 DVDs, so 7 permutations of 7. And when you multiply them together, you get a gigantic number, 604,800. Everybody liked these questions in Algebra 2, remember? It was like the moment right around spring break, like right now, and you learned it, and you're like, oh, this is fantastic. And then they taught you something else right after this, and you're like, that's not fantastic. This was like your reprieve in Algebra 2? Yeah, I know, I remember, because I'm teaching it right now. Okay, so you're going to do all the circled problems on, where's your homework check at? What does it say? Probability. So it goes worksheets 3, 4. Now you can do worksheets 5 and 6. All the circled questions, okay? They go very fast. They do go very fast, I promise. And I posted the answer keys yesterday. I don't know if I posted too many worksheets. I just kind of posted them all together in one big file. All right, do me a favor. Put that off to the side and go find your yellow packet. Where's it at? There. And I have no idea where we left off first hour, because you guys are actually further than everybody else. 18. 18 on the back of the first page? Okay. Oh, that's a fun one. It's like, I don't know. It's fun for me. It's not so fun for the kids, but it's fun for me because I've given this packet out. It's a little different for Algebra 2, but a similar packet out in Algebra 2 as well yesterday. And I asked every class the same thing when I handed it out. I was like, okay, what's your first impression of this packet? And everyone kind of had the same impression, whether you were an Algebra 2 child or a PreCalc child, and all of your impressions were, my goodness, that's a lot of words. And that's kind of our battle. But as we're going through this packet, hopefully you guys are realizing the math isn't hard in these questions. It's the words. Yes, those are difficult, but if you're looking for a reprieve from math calculations, and like that's not your forte right now, if you're a good reader, these should be easy ones for you to get. Now, those of us who are like, well, I'm not a great reader, or I don't read very carefully, let this be your moment to shine. Step up, okay? We need to read carefully. So let's take a look at number 18. A survey was taken of home values in the country, and it was found that the mean home value was $165,000, and the median home value was $125,000. Which of the following situations could explain the difference between the mean and median? Okay, first of all, translate the mean and median idea for me. What does mean mean again? That's average. And then median is middle. So this is actually kind of a box and whisker plot idea. They're talking about the skewedness of the data based on outliers. So let's think about this, guys. You have a mean of 165,000. But the median, the middle, is below it at 125,000. So the homes have values that are close to each other. There are a few homes that are valued much less than the rest. There are a few homes that are valued much more than the rest. And many of the homes have values between 125,000 and 165,000. So can you tell that this data is skewed? What signifies that this data has been skewed? The fact that the average and the median are not the same thing. If it's not skewed data, you should see them overlap. The measures of central tendency should be similar or the same. These are not. So when the mean is higher than the median, that means you have home values that are higher than the norm that are pulling your average up, away from the true center. So with that being said, is it B or is it C? Sorry for the spoiler alert, but it's one of those. Is it few homes that are less or few homes that are much more? Yeah, it's yes, it's C. Do you notice the word outlier didn't show up there? But what they're trying to tell you is that there's an outlier that's on this side? Yeah. That's irritating. I just wish they just used the dang vocabulary. It's not like that's a crazy word. Even a kid not in probability class would be like, outlier, that feels like it's outside. I don't know, whatever. SAT, you bother me. Ooh, they're going to come yell at me now. Whoosh. All right, we are on next page. What are we on, by the way? Oh, calculator. You'll find most of these questions on the calculator section. I don't know why, because most of them don't need a calculator, but it's nice to have your binky with you if you need it. These are multiple choice questions, so that's good. We have 300 students chosen at random from 2 schools, and they were asked how many siblings they have. Cool. The table has shown the results. There's 2,400 students from Lincoln and 3,300 students from Washington. What is the median number of siblings for all the students surveyed? Ooh. That's not so fun. Okay. Anyone have a plan for this? There's a bunch of ways we could approach it. What are you thinking? You're going to cross off stuff? Okay. What you might want to do, though, first is maybe do a little adding. So we don't, like, cross off. I mean, I could probably tell you which one's highest and lowest, but, like, it's my SAT. I'm a little nervous. So can we just come up with some totals here? Like, that's 260. And that's 190. And that's 90. And that's 40. And that's 20. Well, that's beautiful. I bet you guys want to cross off right now, don't you? Yeah. You're not supposed to. Because it is not a matter of the list in the order. It's going to be close. If you did that, you probably might, okay, you'll probably luck out and get the right median. However, do you notice there's a lot of kids in that first group? And then a lot of kids in that second group? And then it trickles down from there? This is actually a frequency table. So guys, how many total students were surveyed here? Okay, 600. And thank you for adding that. Although now that I look back at the data, I realize I could have just answered that myself. My bad. Okay, so 600 students in total. Who would be the middle number for 600? 300-ish? Yeah, it's actually not 300, but because 1 and 600, it'd be like a point something, wouldn't it? Yeah, it'd be like the 290, whatever. Anywho, around 300. Where would 300 sit in your order here? Between these two. So now tell me who's the median. the 300th kid. Like, do you see what this is saying? There's 260 kids who answered 0. So if you put all of your answers from all 600 kids in a list, it would go 0, 0, 0, 0, 0, 0, 0 for 290 kids. And then the next 260 kids. The next 190 kids would have answered 1, 1, 1, 1, 1. So if I was looking at like an Excel spreadsheet and I needed to find the 300th list, part of the list, that kid would have answered what? 1 sibling. The median is 1. That was a nasty little question, wasn't it? Can I share a little secret with you? Because you're pre-calc and you actually could have figured this out a little easier. Oops, I didn't want to erase that. Dang it. All right, so that was 260, 190. You guys could have done a frequency table. You could have put this into list 1. You could have put this into list 2. And remember when you guys do one variable stat and it asks you for a frequency list? You would have made list 2 your frequency list, and it would have automatically like put 0, 0, 0, 0, 0, 0, 0 like in its calculations. Neat, huh? Not neat. Okay. So if you notice you have a frequency list going on, which often these tables have frequencies, like tally marks essentially. If you're not sure you're calculating it right and you're on the calculator test, then enter the data into the list. Do you guys want me to explore that on your list with you real quick so I can show you? Okay. So go to stat, go to edit, enter the answers into list 1 for like 0, 1, 2. And then we're going to, oh, did I just have that data? Oh no. That would have been cool. I don't think I've done this problem on the calculator. Okay, so what do we got here? 0, 1, 2, 3, and 4. And then I should probably ask you guys to give me these numbers because I'm adding in my head. So this is scary. Make sure I'm not doing anything stupid, please. Okay, so I have all of my answer options in list 1, and I have the tally marks in list 2 is what's happening right now. So we're still going to go to stat, calc, one variable stat, because I still want one variable stat. List 1 is where my answers are, and then list 2 is the frequency list. So this time I'm going to put something in frequency. We usually leave it blank. So rather than me literally entering 0, 0, 0, 0, 0 260 times, the calculator has it. And look what happens. If you scroll down, you get your median of 1. Nice calculator, thanks. That was tricky, wasn't it? Yeah, when they put data into a tally table and they don't show you, like, you don't think of them as tally marks or answers, you gotta stop and slow your roll on that question, guys. That was a hard question. All right. Moving back to, let's see, is that the same question? Oops. Oh, yeah, so it was 1. Okay, next question. Oh, same data. Based on the survey, which of the following most accurately compares the expected total number of students with 4 siblings at the 2 schools? Now, your data on your calculator is not separated by the 2 different schools, is it? It's combined data, so don't bother going back to look at your data from your calculator. It's going to be not correct. You could enter it into 2 separate lists at this point, but I think that's going to be a little overkill for this question. Look at the sample sizes from the schools. How big were the schools? So Lincoln is 2,400 kids and Washington is 3,300 kids. So you have to kind of keep that in mind for what their answers were. So I already forgot what the question was. In regarding 4 siblings. So 4 siblings, it looks like they're the same, right? At the chart. Oh, the 10 kids and 10 kids. But when you go and compare it to the size of the schools, that data's not really the same at all, is it? So at Lincoln, because they have fewer students in total, 10 students out of the 2,400 is a higher percentage than 10 students out of the 3,300. So look at your answer choices and figure out which one makes sense. Where is my question? There it is. The total number of students with 4 siblings. Okay, oh gosh, read. It will not be equal, I know that. The total number of students with 4 siblings at Lincoln is expected to be 30 more than at Washington. Didn't I just say the opposite of that? Didn't I say Washington would have more? No, what did I say? Okay. Yes. Okay. So 10 out of, do I have the right school? 2,400 compared to 10 out of 3,300. Total number of students with 4 siblings at Washington School is... Okay, so... Oh, I don't know what's going on here. I have one circled, but now I'm second guessing it. Do you notice how, like, these two are very similar but opposite, but these two are very similar as well? And they both say they're going to have more than at Lincoln School. Huh? B and C are similar but opposite as well. So now I have to make a decision what's going on. I'm having a tough time reading. Ah. Okay. Just a moment. Let me look closer. The total number of students with 4 siblings at Lincoln School is expected to be 30 more than at Washington School versus the opposite of that. Go back to your data. Oh, guys, I'm so dumb. Stop, stop, stop. How many kids did they survey? 300. Why am I so confusing today? Okay, what percentage is that? Is what? 0.3 repeating, right? 10 over, okay. So 0.33 or 33%. Now let's talk about the populations. Wait, what? Yeah, like I said, 0.03. What are you talking about? 0.03 times 2,400 and 0.03 times 3,300. Jeez, I'm confusing today. What are these numbers? Okay, one more time. And? Okay. And I should probably mark who this is. This is Washington, and this is Lincoln. So now I can see with actual data, this makes me feel better, that Lincoln has fewer. So, C. The answer is C. Gosh be golly. That was really stupid, Abruzzo. You need to take a break. And I'm going to, because the bell's going to ring in like a minute. Sorry, everybody, whoever watches this video. Let's delete that. Who's going to show me how to edit a video?